AP Calculus BC in 5 Day 6 lesson. We're going to learn a new integration technique. It's the reverse of the product rule. So we've never actually had a reverse product rule, which is kind of weird because that was one of the earlier rules for derivatives we learned last year in AB. But we never learned the reverse of it. So we are going to figure that out today. Now, just as a quick reminder, this is the product rule, kind of written in, U and V are going to be common letters that you'll see in formulas for the product rule, reverse product rule. It's called integration by parts, by the way. So I'm going to take, this is, the product, you take one times the derivative of one part, and then the other one times the derivative of the other part, and you add them together. That's the product rule, pretty simple rule. We use it all the time. I'm going to rearrange this, okay? So I'm going to get the u v prime over here on the left. So I'm going to kind of flip sides. So then I have the u v prime here, and then minus vu prime right here. So I just, I flip the sides and subtract this to the other side. I'm then going to integrate both sides, okay? And you can break it up into separate terms, that's fine. And so then, I guess I could wrote that as a separate step, but that's fine. Okay, so uv prime. Now, you're integrating the derivative right here. So they just cancel each other out and you just get uv, right? Minus vu prime, okay? So this is the rule. I'm going to show you guys how it gets used. And probably, probably not going to memorize it with the letters so much as more just the pattern. So we got to try and kind of see a pattern here, okay? This rule is going to be applied when you have two things, usually, multiplying each other, and one of them you're going to designate as the derivative of something and the other one not. But then their derivatives and antiderivative show up over here. So, like in this case over here, we could say that this is our u and this is our v prime. And the answer should be uv, okay, minus vu prime, okay? Now, I think it's going to help to be like, all right, well, u equals x, and v prime equals e to the 2x dx. And the dx should be part of that, the derivative. So we already have the u. We're going to need the u prime. So we're going to take the derivative of this, and it's going to be just 1 dx. We have v prime, but we're going to need v, right? So we need to integrate both sides to get v, which is going to be e to the 2x with a 1/2 because of the chain rule, right? And the dx is gone. So u and v, so u is x, v is 1/2 e to the 2x minus the integral of vu prime. Now, I feel like it's easy to remember that this is uv. And this, I think of as the two new things. The two new things are the thing that always goes inside the integral. The two new things. So it's going to be 1/2 e to the 2x dx. So one of them supplies dx for you. So now we could rewrite this a little nicer, 1/2 x e to the 2x, and then we can actually integrate this, right? Minus 1/4 e to the 2x plus c, of course, always plus c at the end for indefinite integrals. That's how you do it. Now, by the way, you guys couldn't have integrated this original one. With all the things I've taught you over the last year and a half, you couldn't do that. But now we can, okay? Now, one of the hard parts is that you can mess up is whatever you pick to be the u and the v prime, you can mess that up, okay? So usually the u is something that hopefully gets simpler when you take its derivative. Like the derivative of e to the 2x is still e to the 2x. The derivative of x became 1. So usually the thing that, if you take the derivative, it becomes simpler, is probably the right choice. But there is a actual defined order of what should be the u, and therefore what should be the u prime. V prime would be the other one. So LIPIT is a nice little acronym to remember. LIPIT. L stands for log. I stands for inverse trig. So inverse trig is higher up on the list. P stands for polynomial. E stands for exponential. And T stands for trig, regular old trig. So this is the order, higher on the list, takes precedence, what should be the u. So the first thing you do when you see one of these problems, I mean, try all your other methods, please. But you can't integrate this. So you'd be like, okay, well, I have a poly, x to the first power is polynomial, and I have trig, so I have poly and trig. So here's, poly and trig. So which one should be the u? The one earlier in the list. So this one needs to be the u, and this one needs to be the v prime. So that's the first challenge here. Now I would write these down. U equals x, v prime equals sine x dx. Okay? So then you're going to need to find u prime, which is 1 dx. You're going to need to find v by integrating, which is going to be cosine x. So you got to do that. And now you got to remember the pattern. So remember it's uv. So the u and the v, whatever they are, u cosine x, minus the integral of the two new things. Remember, it's the two new things. So it's going to be cosine x dx. That's how I remember it. Instead of trying to remember all the u's and v's and all that stuff. uv minus integral of the new stuff. The hard part's making sure you pick the right u and v prime. So the answer to this is going to be, and I feel like, did I make a mistake? Oh, this should be negative cosine. So there needs to be a negative here and then another negative here. So this is going to be negative x cosine x plus. The antiderivative of cosine is sine plus c. That's the answer. And we couldn't have gotten that before today. All right. So let's look at some special cases and just try a few more practice ones before you do them on your own. So in this one right here, we have polynomial and we have trig, right? And polynomials earlier in the list. So I mean, I'd be writing LIPIT every time as like a nice little checklist next to my work. And I'd be like, oh, okay, poly comes before trig, right? So that's your u. The other one has to be v prime. So I'm going to write them down. U equals x squared, v prime equals sine x dx. So then u prime equals 2x dx, and v equals negative cosine x. All right? So then we're going to put them in the pattern. So it's going to be uv, negative x squared cosine x, minus the integral of the two new things. So negative 2x cosine x dx is a nice way of writing it. Plus. Okay, now can we integrate this? Usually, hopefully, the new integral is something we integrate. We can't integrate that. Guess what? We have to do integration by parts again, all over. Now, I'm going to ignore the 2, just put the 2 out front. So it's like that. This is poly, and this is trig. So poly is going to be your u, trig is going to be your v prime. So u equals x, v prime equals cosine x dx. U prime equals 1 dx. V equals sine x. And so the first part's still there, negative x squared cosine x, plus 2 parentheses, because we're going to put a whole new integration by parts, uv x sine x minus the integral of the two new things, sine x dx. But this 2 and everything right here has to be distributed to all this stuff. So better put parentheses around all this. Okay, negative x squared cosine x plus 2x sine x the antiderivative sign is negative cosine, so we get plus 2 cosine x plus c. So we call that repeated use because we had to do it again to finally get our answer. I mean, it could be repeated 3-4 times. Now, the repeated use ones really, that things get kind of gnarly there. There is a shortcut that works for repeated use or even non-repeated use just one time, and this shortcut is awesome, but it only works for certain cases, okay? So I'll show you how the shortcut works, okay? So this is the problem we just did, right? This is the problem we just did, so we should get the same answer. In the movie Stand and Deliver, Jaime Escalante, in one scene, kind of refers to it as tic-tac-toe. And anyways, I don't know if you haven't seen that yet. Hopefully you'll see it. One of my favorite calculus movies. So anyways, we start with it, and the thing that, again, u is usually the thing that gets easier when you take a derivative, it becomes simpler. So the thing that, take the derivative of x squared is 2x. The derivative of 2x is 2. The derivative of 2 is 0. You want to keep going until you get a 0. Keep taking derivatives, okay, until you get a 0. All right? And the other one you want to integrate repeatedly. Antiderivative sign is negative cosine. Antiderivative of negative cosine is negative sine. Antiderivative sign is cosine. Until you get to the line with the 0 on it here, then you're good. So once you get to 0, you're done. This one you need to keep going, integrate these. Now the answer ends up being this guy times this guy, this guy times this guy, this guy times this guy. And once you get to 0, you're done. So you're going to kind of multiply these down at a diagonal, tick, tack, toe. But there's also another extra thing you got to worry about. The first one's positive, the next one's negative, the next one's positive, the next one would be negative. Alternate, starting with positive, negative, positive. It has to be applied to it. This comes from the minus of the integral of the new stuff, right? And so the second time through, it became a positive, right? So that's where that comes from. So the answer is going to be negative x squared cosine x, right? Plus 2x sine x plus 2 cosine x plus c, done. I mean, that's pretty nice. Same answer, look, right? Same answer. You got to get the pattern down. Make sure you know how to use it. If you're going to use a shortcut, you better know how to use it. Otherwise, you should just do it the long way. Because if you don't know, if you clearly don't understand the shortcut, I'm not giving you any points. You better just do it the hard way. No understanding shortcut. So we want to always check for the shortcut. It only works for certain situations. So lipit, it only works for polytrig or polyexpo. Okay, nothing with logs or inverse trig. It's got to be polyexpo or polytrig. Polyexpo or polytrig. That's the only place it works. So you got to have a polynomial that you take derivative of and eventually goes to 0, right? If it doesn't, then this doesn't even make sense. Okay, this is a cool trick that is especially helpful on repeated use, but also helpful on even single use ones. It's faster than just having to do the normal thing. Let's try some examples. I think you guys should try these. Try one, pause the video, try it, and then we'll go over it. And then you'll try the next one on your own, and then we'll go over it. You need to get the hang of this. You're not going to get the hang of it miraculously by watching and copying me do a bunch more down. You need to try it, okay? So see if you can try the first one. Now, what I would be doing is I'd be writing lipit next to each problem, because you got that's critical, right? So we got poly and we got inverse trig, right? Poly inverse trig. Which one is on the list first? This guy. This is your u, this is your v prime. So u equals inverse tangent of x dx, and v prime equals x dx. This guy shouldn't have the dx. The dx is the derivative. Now, it's going to be clear if you put inverse tangent here, trying to integrate inverse tangent, we've never done that. So that'd be an obvious bad choice. So we need to take the derivative. Derivative tangent is 1 over 1 plus x squared, right? Dx. Over here, this is going to be v equals 1/2 x squared. Okay. Don't need to worry about the plus c's right now. It'll get built in later. So now we need to write this down. Okay. Now, by the way, check. Can we use a shortcut? Is it polyexp or polytrig? Nope. No shortcut. Always check to see if you can use a shortcut. It'll be totally worth it. Can't use a shortcut. Okay. So this is going to be uv. So 1/2 x squared inverse tangent of x minus the integral of the two new things. I'm going to put the 1/2 out front. But it's going to have x squared over 1 plus x squared dx. Now we got to figure out how to integrate this. You're like, well, how do I integrate that? Can we use partial fractions? No, because the degree of the top is equal to the bottom. Oh, we should try long division. I mean, do you have any other ideas? U-substitution doesn't work. It's not an inverse trig. Long division. So I'm going to do x squared plus 0x plus 1 divided by x squared plus 0x plus 0. First terms, it's going to be a 1. It's going to be x squared plus 0x plus 0. We're going to subtract. And we're going to get a 1 remainder. So the other stuff in front just stays the way it is. But this is going to be 1 plus 1 over 1 plus x squared. We can integrate that. So it's going to be 1/2 x squared inverse tangent of x minus 1/2 x minus 1/2 inverse tangent of x plus c. Wow, that was kind of crazy. I brought a lot of stuff in. Long division, inverse trig, integration by parts. That's what this is called, integration by parts. Okay, try the next one. Pause the video. Try the next one. I'd write lip it down. Okay, pause the video and try it. We got poly and we got expo. Poly and expo. Hey, we can use the shortcut. Use it. Otherwise, you're going to have to do the repeated use 3 times. It's not going to be good. Whichever one's the one that, if you take derivative of, gets simpler and eventually gets 0 is the one you want. So derivative of x cubed is 3x squared. Derivative of 3x squared is 6x. Derivative of 6x is 6. Derivative of 6 is 0. You want to keep going until you get 0. The other side, you got to integrate. Now watch out for chain rule. It's going to be e to the 2x with a 1/2. Then it's going to be e to the 2x with a 1/4. It's going to be e to the 2x with a 1/8. It's going to be e to the 2x with a 1/16. Because the chain rule. Plus, minus, plus, minus, plus. Okay, starts up here at the top one. And then we go down the diagonal. So the answer is going to be, this is way faster to do it the long way. 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 3/4 x e to the 2x minus 3/8 e to the 2x plus c. Don't forget the plus c. All right. Okay. You guys try the next one. Pause the video. Try it. Get stuck. Get an answer. Unpause it. I'll show you how to do it. Pause again if you got stuck and see if you can finish it. Lip it. Okay, this is poly. This is log. So we got polylog. Can we use a shortcut? Nope. No shortcut. Shortcut's polyx, but polytrig. No shortcut. So u equals, u is the one earlier. So the log is u, and the poly is v prime. So u equals natural log x, and v prime equals x dx. Now this should make sense, because if you're trying to integrate natural log, you guys don't know how to do that. And by the way, you guys can't integrate this until today. You couldn't integrate this any other way. U prime, not bad, 1 over x dx. V, 1/2 x squared. Okay. UV, 1/2 x squared, natural log of x, minus the integral of the two new things. I'm going to put the 1/2 out in front. And, I mean, we could write this. It's going to simplify to just the integral of x, right? Power rules of exponents. So this is going to be 1/2 x squared, natural log of x, minus 1/2 x squared over 2 power rule plus c. Final answer, 1/2 x squared, natural log of x, minus 1/4 x squared plus c. That's how you do it. All right. The next one's kind of interesting and confusing. I just talked about in the last problem that if you try to integrate natural log, you can't do it. Okay? See if you can come up with a creative way. This one takes a little creative step, because all the problems we've been doing have two things multiplying each other, right? That's kind of the critical thing, because one's going to be the u, one's going to be the v prime. This only has one, but I want you to think of this. Try and think a little hard about this and think, could it be seen as two things multiplying times each other? And if so, how would it work? So see if you can try it. Pause the video if you want to give it a shot. I'm going to think of it as, I'm going to go and tell you guys how to do it. So hopefully you've tried it. I'm going to think of it as 1 times natural log, right? Anything could be 1 times it. And I'm going to think, what would 1 be in our lipid list? That would be a polynomial of degree 0. I could call it polynomial. And then we got log. So we got polynomial log. Can't use a shortcut, right? No shortcut, because that would be polyx but polytrig. No shortcut, okay? The u, which one's going to be the u? Well, earlier in the list, the log is going to be the u, and the poly is going to be the v prime. So u equals natural log of x, and v prime equals 1 dx. U prime is 1 over x dx. V equals x. So we're going to write this. It's going to be uv, x natural log of x, minus the integral of the two new things, 1 over x times x dx. That's just going to become 1. X natural log of x minus x, the antiderivative of 1 is x, plus c. This is the antiderivative of natural log using this new technique. Kind of crazy. I don't want you to memorize this, because you won't use it often enough to remember it correctly. I want to use this method, okay? So assignment is 5-6. Try the problems. Check your answers. And let's see if we can start to get a hang of this cool new reverse product rule technique, integration by parts. Tic-tac-toe.